Hello and welcome to a study of mushrooms. Knowing the basics of mushroom morphology can be extremely useful when trying to draw mushrooms with a higher degree of complexity and realism. That's why in this video we will go over the main elements that make up a mushroom, discuss the role they fulfill, and highlight what I find to be some interesting variations of those elements. With that being said, let's get to work. First, let's define what a mushroom actually is. A mushroom is just one part of a larger organism, namely the fungus. Fungi are not plants, they are a completely separate kingdom. There are also many groups and types of fungi, and not all of them produce mushrooms. A mushroom is also known as the fruiting body of a fungus. This refers to the fact that the mushroom is responsible for the production of spores, which are necessary for the fungus to reproduce. And with that in mind, let's take a look at the life cycle of a mushroom-producing fungus. This is a simplified illustration of the entire process. But generally, once a spore has landed in a suitable habitat, it starts growing into what is called the mycelium. This mycelium is the main body of the fungus, a root-like structure hidden from sight made up of a vast number of microscopic filaments called hyphae. Now, there are quite a few things that need to happen before the mycelium is ready to produce mushrooms. But for our purposes here, it's enough to know that once all conditions have been met and fruiting bodies can be produced, a bunch of hyphae clump up together, resulting in a hyphal knot. This then grows into a so-called primordium, which is the first growth stage of a mushroom. From there, the development continues, going through the immature button mushroom stage and eventually arriving at the mature mushroom. At this stage, the fungus can release its spores, which would then be carried by the wind towards a potential substrate in which to germinate. If we take a closer look at our mature mushroom, we can see that at the bottom there is this shell-like element called volva, also referred to as a cup. This cup is a remnant of the universal veil. And before we get into what the universal veil is, it's important to note that not all mushrooms sprout from a universal veil, but the ones that do usually have some residual tissue at the bottom of the stem, which represents the volva. In some cases, this tissue is easy to see, but for some mushrooms, it's much more subtle in appearance. Now, the universal veil is basically a capsule that covers and protects the mushroom in its early stages of development. Once the mushroom emerges from its protective hull, the universal veil can sometimes, but not always, leave pieces of tissue on top of the cap. Depending on the properties of that tissue, the remnants can be anything from a single large chunk, like in this illustration, to multiple smaller pieces, like in the case of this mature mushroom. An important point here is that what might seem like remnants of a universal veil can in fact be just the surface texture of that mushroom. The difference between them is that volval patches are separate elements and can be removed from the cap by rain or friction, whereas the surface texture is simply part of the actual mushroom skin. The stem of the mushroom, also called stipe, serves as its main support structure and depending on the species can vary in thickness, surface texture, and shape. If we go a bit further up the stem, we come across the so-called annulus, a remnant of the partial veil. And just as we had it with the universal veil, the partial veil is not always present in a mushroom. In the case of mushrooms that do have a partial veil, the resulting annulus can vary quite substantially in appearance from one species to the other. To understand what the partial veil is, we can look at this representation of a button mushroom. Here we can see that the cap and stem are connected by a tissue. This tissue is designed to protect the spore-bearing structures of the mushroom. As the mushroom grows, that tissue breaks, revealing the gills underneath. And whatever piece of tissue remains on the stem is what constitutes the annulus. Now let's look at a few examples of how such an annulus might look like. The first one, what I would call a more classical version, is known as the pendant variation. In this case, the annulus settles down, kind of like a piece of fabric. We also have a so-called flaring variation where the annulus remains in this sort of upward position. We can have a solid ring or a barely noticeable light ring. We can even have remnants of the partial veil that stick to the margins of the cap. Some species of mushrooms have partial veils that can crumble and stick to a larger section of the stem. And some mushrooms have this sort of fibrous tissue that stretches and starts to slowly tear itself apart as the mushroom grows. The next part we are going to look at are the lamellae or gills. This is where the spores of the mushroom are produced and where they are released from. I would say that this type of spore-bearing structure is the one that most people are familiar with. However, there are other, completely different types of spore-bearing structures, some of which I had no idea even existed. But before we take a look at that, let's go over some of the ways in which a quote-unquote common gill can attach to the stem of the mushroom. On this page we have multiple illustrations of various mushrooms where the front left quarter piece has been sectioned out. This is just so we can see the exact shape of the gill with its corresponding attachment type. Now the first, and I would say most basic attachment type, is called adnate, where the gill attaches broadly to the stem. Then we have the so-called decurrent attachment type, where the gill runs down the stem for quite a distance. Free is where the gill does not attach to the stem at all. Sinuate is where the gill is smoothly notched and then runs briefly down the stem. And finally, we have a really peculiar one called emarginate. This is where the gill becomes all of a sudden much shallower just before attaching to the stem. When it comes to spore-bearing structure types, there are 4 main variations. First, we have the gills, which we talked about previously. Then we have the so-called false gills, which are basically folds on the surface of the mushroom's body that are not separate from it. True gills are separate elements that can be broken off individually, false gills are not. Some mushrooms have pores as their spore-bearing structure. And finally, what I believe to be the most peculiar variation, we have mushrooms with teeth or spines. Moving further up, we get to the iconic cap of the mushroom known as pileus. It has the role of protecting the spore-bearing structures underneath, and it comes in a variety of shapes that can even change as the mushroom grows. To name a few, we have the conical shape, the flat version, which is usually present in the case of mature mushrooms, infundibuliform, which refers to a funnel-shaped cap, the rounded convex variation, and the bell-shaped cap known as campanulate. The margin of the cap is also an area that can display interesting characteristics. You might see striations, remnants of the partial veil like I've shown you before, or sections where the cap started to break and split as the mushroom matured. Our last piece of the puzzle is the Volval Patches. I've touched on them before. They are remnants of the universal veil that stuck to the cap of the mushroom as it grew. This particular illustration is that of a Amanita muscaria mushroom, which is the real-life Mario mushroom. And as you can see, the white dots on the cap of the mushroom are not splotches of white, but are separate pieces of tissue that can actually be brushed off. As a side note, this mushroom is also highly poisonous, so if you see one, be careful, don't just randomly pick it up if you don't know what you're doing. Now, before we wrap this up, I do want to emphasize that this study focused on the morphology of what is generally considered to be the classic-looking mushroom. However, there are mushrooms out there with unique looks that deviate pretty far from the norm. For example, we have this peculiar mushroom known as the veiled lady, or this incredible rounded cage-looking mushroom. The so-called fluted bird's nest has these actual egg-looking pellets that contain the spores of the mushroom. And finally, we have this alien-looking mushroom known as the devil's fingers. Alright, here we are at the end of our exploration. I'll be honest, studying mushrooms turned out to be much more difficult than I expected. I was pleasantly surprised by how much variety and complexity there is in the world of fungi. There's also quite a bit of information that I left out, especially regarding the way some fungi operate, the way they absorb nutrients, and the role they play in the ecosystem. That's because I think this information wouldn't necessarily have any relevance in the drawing of a mushroom. However, if like me you do find this subject interesting and want to dive deeper into the inner workings of these fascinating organisms, you can find some links to various resources I used in the description of the video. In any case, that's it from me. Thank you for watching, and I hope you'll join me next time.